Well, good day, viewers. We're back working on this EcoBoom 2012 with a parasitic draw. I left the ammeter on it all night. It's about 105 milliamps, which is a little too high. So it's the next day. We're back working on this 2012 F150 for a parasitic draw. In the previous video, I found a broken wire between the door and the pillar, keeping the interior lights on, but that shouldn't have killed the battery because the BCM should shut down the interior lights after 15 minutes. Then the draw dropped about 2.5 amps. I found the two sun visor mirror lights on because of broken hinges or worn hinges. And then it still dropped down to about 2.2 amps. And then I was playing with it, pulling fuses, and it dropped to 106 milliamps, and it's been 106 milliamps. But you can see over the course of the night, because it's been recording since yesterday at 8 p.m., the current draw exceeded 200 milliamps, because that's what the arrows indicate. 104 minimum and maximum overload. Now, I don't think this recording would have caught anything. I'll back up in the recording and look. So we're looking at the record on this thing, and I was doing some research last night, and I noticed that one of the codes that I kind of passed over on the initial scan yesterday was this B1277-15, reverse lamp circuit short to battery or open. I thought, well, maybe it has a bad bulb or something back there. I went on Identifix and I did a keyword search for battery drain, and I come across a couple of cases. Where is it here? Okay, battery drain. Connector 405. Vehicle has a battery drain that will deplete the battery overnight, such as the engine will not crank. The Prundle is showing proper transmission, shift lever in all ranges, including park. Connect the DVM to fuse 53 at the battery junction, and then remove fuse 34 of the body control module to determine if the voltage fuse 53 drops. So I'm going to do this. The bottom line is corrosion in connector 405. Clean connector 405, which is at the back of the truck, causes a bleed of voltage from one of the electrical circuits in there, and of course the BCM controls all the tail lights, including the backup lights, and somehow that bleeding voltage bleed from a hot at all times circuit to the violet brown wire. So I'm going to look at this circuit and try and establish whether that's a problem. We're going to look at connector 405, which is right by the rear bumper, and considering this thing is in northern Ontario where we have lots of salt and corrosion, there's a very plausible possibility here. So we're looking under the back of the truck. That's connector 405 that you see there up on top of the frame rail cross member beside the left side of the spare tire at the very back. And it's clipped to the body of the truck. But I think I'm going to try a couple of electrical tests before I go and try and pull that connector apart. So the technician instructions say, before extensive testing is performed, connect the DVOM to fuse 53 of the BJB, which is the battery junction box right here. Fuse 53 is this one right here, 5253. So that is this second 5 amp fuse right here. And I'm reading 3.143 volts on it. So it says, with the ignition off, which it is, the removed fuse 34 of the body control module determines the voltage on fuse 53 drops away, suggesting the source of the drain is downstream of fuse 54 or 34. So let's remove fuse 34 from the BCM. So fuse 34 on the battery or the BCM is this one right here. So it's 1, 2, 3, 4, 5, 6 up from the bottom. 2, 3, 4, 5, 6. Is that fuse even live? I hope I'm on the right fuse. I don't think that fuse is even live. That one is. So 1, 2, 3, 4, 5, 6. Let's double check that. One, 2, 3, 4, 5, 6. The second row. They're not numbered on the junction box, but that fuse is not even live. But that doesn't mean there's no voltage there. It doesn't light a test light. 1, 2, 3, 4, 5, 6. So that's the second 10 amp fuse. I need a pair of needle nose pliers. So there's the fuse out of that location. Let's go check and see if we still have voltage on that wire, or on that fuse 54, I think it was. 53, fuse 53. Survey says, look at that, 0 volts. So what does that suggest now? If the voltage drops away, suggesting the source of the drain is downstream of fuse BCM fuse 34. If the drain is found to be downstream of fuse 34, check connector 405 and C4000 for potential water intrusion or corrosion that may cause the issue with backfed voltage from the harness, and thereby preventing the PCM from properly deactivating the PCM power relay. Refer to related documents for wiring and connector information. Note the violet brown wire is generally still present in the vehicle through these connectors, even if the vehicle is not equipped with a video camera. Interesting. Let's get at that connector. So I have to drop the spare tire, and this little cap over the spare tire lock was hanging down. So as you can imagine, it's damn well seized, of course. Oh well, spray some penetrating fluid in there, see if we can get it working. So with that fuse 34 removed from the BCM, which by the way had no voltage drop across it when I measured it yesterday, the current draw has dropped to 26 milliamps, which is perfect, acceptable. I want to see what that fuse feeds. I can't get that spare tire retainer down. So fuse 34 in the BCM feeds parking aid module and a video camera, and this is for a SVT Raptor, which this is not, and that goes through connector 212, 1581, 405, 4000. So it could be any one of these connectors. But I bet you if we measured the voltage at that fuse, I'm sure that's hot in start. So if it back feeds voltage back through that fuse, it back feeds up to this circuit, hot in start power distribution. So that should theoretically be back feeding the heated seat module as well. And hill descent control switch if it has it. No, that's on Raptor. I have a mindset to leave that fuse out. It doesn't appear to operate anything but the parking aid module and the camera. But I got to get that spare tire down to look in that connector. So I got the lock pried it out of the plastic bumper cover. 3/8 long extension to drop the spare tire. Fortunately it dropped. I got that connector disconnected. Looking at that connector, looks pristine. No signs of corrosion or moisture entry in that connector whatsoever. So Yeah, there's battery power to this thing. Well, that'll be telemarketers because nobody calls me on that number. So we're back down to 25 milliamps. And I'm going to put the fuse 34 in the VCM back in. Okay, fuse 34 is the second one in the middle, right here. Let's see if my voltage came back, or if my parasitic draw came back. 105 milliamps. And if I got a voltage on this fuse 53 again, 3 volts. So it's obviously not from that connector because I got it unplugged, unless there's salt water in the harness side of that connector. So let's have a look at the electrical diagram. So we have several connectors. We got 212, 1581, 405, 4000. 4000 is on the way to the video camera, so let's put it at 1581. This hyperlink doesn't work? Oh, that's a print. What diagram is this? F33, F34, F35. I got to get a version of this diagram because these hyperlinks don't work. So here is the version of the schematic. So we're at 405. Let's try connector 1581. Where is that located? Should be under the chassis of the vehicle. Really? Why would it be over there? Well, how many pins in that connector? That looks like a pretty big connector. Well, yes, it is. And there's nothing downstream between there and 405? So we should go to connector 405, pin 11, this violet wire, and measure the voltage on it and see if we got a voltage at that connector under the truck. Well, that's connector 405. And that's not the connector I have apart. The connector I have apart is different from that one. So there's another connector up there. Let's see that 405 where it exists. Location. I know it was at the back of the vehicle, but the diagram is pretty vague. So that would explain why it's not affecting anything by disconnecting it, because I think I'm on the wrong connector. Come on, load the picture. See, there's a bunch of connectors there. So I think I'm on this connector here, and I need to be on this connector. Alright, let's get a picture of that connector face again. So it's a 16-pin connector, rectangular. And the color of the connector is black. Well, that narrows it down. So it turns out there's another connector right here. And I've disconnected that, and it's full of water. Imagine that. damn. Pin 11 is this violet wire right here. This purple wire, the second one in. Green corrosion. Well, let's get some air pressure and blow this out and dry it out and deoxidize it. So I got both fuses back in, or the fuse in the BCM back in. Got that connector blew out, deoxidized with deoxide spray and packed full of dielectric grease. Now we have 0.010 volts on that fuse. And the draw now is 17 milliamps. So that appears to be it. I'm going to put this all back together again and check it one more time for a parasitic draw. Okay, so now I put the car starter back in and all of the electrical back together as original, and we're reading 36 milliamps, which is acceptable. It was down to around 17 to 20, but that car starter module does draw a little bit. Yeah, I'm gonna curious. I want to plug in the DLC connector and see if we have communication with any modules now. So I've got the key out of the ignition. I got the DLC connector plugged into the VCMI for this Ferris Edge, and we're going to do a code scan and see if anything reports anything. I don't have the key on, but I was communicating with a whole bunch of computers before with the key off. There was like 6 or 7 computers. Still got communication with the steering column control module. So I guess initializing communication with the scan tool wakes it up. I wonder if that wakes up the current flow. Certainly does. $650 milliamps, 500 milliamps, 300, 250. So the fact that I still had communication with the BCM with the key off is irrelevant at this point, because you can see there's a bunch of modules that will communicate if asked to, by the looks of it. So we're going to start this vehicle up and do a network code scan again. So I've got the vehicle running. Let's do a code scan again. It says not running, but I know I can do it running. So there's a problem with the engine cooling fan. We had that code before, P0480. Still got these lost communication with the ECM, PCM, and the power steering control module, but those could be from the power problem we had before. A hell of a lot less codes. So let's go back and clear the codes. Switch the ignition off. So we're going to clear all the codes one more time. So if you run across this problem, pull fuse 34 in the BCM. If that makes everything go to sleep, then check the connector 405 for water intrusion. Code's cleared. Okay. Switch ignition off. Let's do a key on engine off self-test of the ECM. See if it resets that fan code. Normally it would run the cooling fan. One fan run. Fan control circuit 1, P048000. Well, I'll discuss that problem with the customer. Let's see what troubleshooter says about the P048000. P047080. For a relay controlled electric cooling fan, monitors a low fan control primary circuit output from the powertrain control module. The test fails when the PCM grounds a low fan control relay circuit and excessive current draw is detected on the low fan control circuit, or when the low fan control circuit is not grounded by the PCM, the voltage is not detected on the low fan control circuit. Possible causes are open or shorted low fan control circuit, open V power circuit to a low speed cooling fan, damaged low speed fan control relay. During the key on engine off self-test, the cooling fan is cycled on and off. A short to voltage can only be detected when the PCM is grounding the low fan control circuit. During the key on engine off and key on engine running self-test, it's duty cycled. Okay. Possible causes: fan control circuit open or shorted, V plus or ground circuit concerned to cooling fan, V power open to cooling fan, damaged cooling fan module. Alright, well, I'll discuss this with the customer, but for now I'm pretty sure this parasitic draw problem is corrected. So I thought I'd take a couple minutes just to check fuses in the relay. So this is a low speed cooling fan relay in the bottom right hand corner of this, and there it is gone. So I'm not sure what's going on with that, but the relay's missing. I might stick one in there and see what happens. Why not? Well, it worked with a relay jumper in there. So the fan motor's not shorted, so let's plug a relay in and see what happens. So we got that relay installed and cleared all the codes. We're going to do a key on engine off self-test again and see if we can hear the fans run. I don't know what that is. And no codes. So the radiator cooling fan works now.